In this video, I am going to be introducing the concept of a limit. The limit of a function is the fundamental concept in the study of calculus, and it forms the foundation for the study of differential calculus and integral calculus. In this video, we're going to take a look at it from a numerical and from a graphical perspective. So let's start with a simple function. And that function is f of x equals x plus 2, a very simple linear function. Looks something like this. Now, if we graph it, here is the y-axis and the x-axis, and I'm just going to move that a little bit over here. And what we want to do is we want to ask ourselves, as the x values move closer and closer to some number, let's say 5, as the x values get closer and closer to 5, what is the function value approaching? Now remember, the function value is the same thing as the y value. And so we can see this over here on the graph, and we'll take a look in this table of values as well. So in the table of values, says that when x is equal to 2, the function value is 4. And we can see that over here on the graph. If I move the cursor around, we can see the ordered pairs. And when x is equal to 2, the y value, or the function value, is 4. Now we're interested in what is happening as x gets closer and closer to 5. Well, in the table of values, as we go from 2 to 3 to 4 to 4.5, 4.9, we're getting closer and closer to 5, 4.99, 4.999. The function values go from 4 to 5 to 6, 6.5, 6.9, 6.99, 6.999. So looking at this table, it would appear that as the x values are getting closer and closer to 5, the function values are getting closer and closer to 7. And again, we can take a look at this on the graph. As my x values in these ordered pairs are getting closer and closer and closer to 5, the function values are getting closer and closer and closer to 7. And finally, when we get to the actual value of 5, x equals 5, the function value is 7. Now I want to say right now, we are not interested in what is happening at 5, which is why I left it blank over here in this table. We're not really interested in what is happening at 5. That would be the function value at 5. The function value at 5, if I put 5 in here, we can see the function value is 7. But with a limit, we're not interested in what's happening at 5. We are interested in what is happening as we approach 5. Now, why we want to do that might not make a lot of sense right now, but as we study the concept of a limit, it should become clearer and clearer why we want to do that. For the purpose of this video, it's important to understand what the idea of the limit is all about. Well, we can come from the opposite direction too. As we approach 5 from larger numbers, in other words, from the right, so we're starting up here at x equals 8, and we move to the left along the curve, we're moving from the right to the left along the curve, we can see as we get closer and closer and closer to 5, the function values are getting closer and closer and closer to 7. And we can see that here as well. As the x values go from 8 to 7 to 6, 5.5, 5.1, 5.01, 5.001, the function values are getting closer and closer and closer to 7. Because the function values are getting closer and closer to 7 as x approaches 5, from both directions, we would say that the limit of this function, x plus 2, as x approaches 5, is 7. Let me say that again, a slightly different way. The limit of the function as x approaches 5 is 7. In other words, as x is approaching 5, the function value is approaching 7. So sometimes it's handy to think, well, think of the limit as the function value that we are approaching as x approaches some number. Right, well, you might be saying, well, what's the big deal? Because as I already said, the function value at 5 is 7, and the limit at 5 is 7. They're the same thing. So what's the big deal? Well, that won't always be the case. Let's take a look at a different function that looks very similar. This function, which is a rational function, if we graph it, actually forms the exact same graph. And why it is the exact same graph is not the topic of this particular video, but it is the exact same graph. And notice that as we approach 5, that this function value is also approaching 7. Okay? So as we're approaching from the left, from smaller values of x, 2, 3, 4, 4.5, up to 4.999, the function value is once again approaching 7. But as we approach from the right-hand side, over here now, once again, we are approaching 7. But here's the big difference. What is the function value at this point? If I put in 5, notice that the undefined doesn't go away. It's still undefined. In other words, the function value at 5 doesn't exist. Now we can see that on the graph. If I put the cursor right on 5, notice that, you can see that, there's a hole there. And it says that at x equals 5, the function is undefined. The function is undefined, but the limit is still 7. So remember, we are not concerned with the function value at 5 when we're talking about a limit. We want to know what's happening to the function as we approach x equals 5. And so as we approach x equals 5 from either direction, the function value is approaching 7. So let's take a look at that. So if we have our first function, f of x is equal to x plus 2, we can say that the limit of f of x as x approaches 5 is equal to 7. And that's what we just determined from the graph. And this is the notation that we use. Now we could also write it as the limit and actually put in the function there, x plus 2, the limit of x plus 2 as x approaches 5 is equal to 7. All right. Now, in this particular case, the function value was also equal to 7. The function value was equal to 7, and the limit was equal to 7. They were the same. But in the second function that we looked at, g of x, and that was x squared minus 3x minus 10 over x minus 5, we discovered that the limit of, let's get rid of that. The limit of g of x as x approaches 5 was 7. However, the function value g of 5 does not exist. There is no function value. So the limit is 7 as x approaches 5, but at 5 does not exist. So the moral of the story here is the function value and the limit are not the same thing. They may be the same, but they are not necessarily the same thing. The function value at a point and the limit of the function as you approach the point are two completely different things. So that's what you need to really understand from this video, and moving forward into doing the homework is understand that when we're looking at a limit, we are looking at what we are doing as we approach a point. What is the function value approaching as we approach a point? not what is happening at the point, which is what the function value tells us. All right, hope this was helpful.